Welcome back to the channel. Today we're diving deep into one of the most classic essential problem types in all of algebra, the work rate word problem. If you are taking pre-algebra, Algebra 1, Algebra 2, or prepping for standardized tests like the SAT, ACT, or GRE, you are guaranteed to encounter these. Many students look at a problem like this and feel overwhelmed because it involves mixed numbers, unknown rates, and wordy setups. But by the end of this full lesson, you will master the universal formula that makes solving any work problem, whether it involves people, machines, or pipes filling a tank, completely straightforward. Anytime you encounter an algebra word problem, never jump straight into writing equations. Apply the 3 read strategy. Read 1. Understand the scenario. Tom is doing a job. Sam steps in to assist, making the job finish faster. Read 2. Pull out the numerical data. Tom alone takes 4 hours. Together, Tom and Sam take 2 and 2/9 hours. Note that both units are consistently in hours. Read number 3. Isolate the target question. We are strictly being asked for the first time it takes Sam alone to complete the entire job. So to understand why the formula works, we need to talk about the concept of a work rate. If Tom can paint an entire house in 4 hours, how much of the house does he paint in just one single hour? He paints exactly 1/4 of the house each hour. Therefore, a person's rate of work is always expressed as the fraction 1 divided by the total time it takes him to complete the job. Write this formula down in your notes right now because it's the key to this entire family of algebra problems. 1 over the first entity's time plus 1 over the second entity's time equals 1 over the combined time working together. This formula simply says that the rate at which person A works plus the rate at which person B works equals their combined rate of work when working simultaneously. Let's explicitly define our variables before doing any algebra. Tom's time is 4 hours, so his individual work rate is 1/4 of the job per hour. Sam's time is our unknown, which we will define as the variable x. This means Sam's individual work rate is 1 over x of the job per hour. So their combined time is 2 and 2/9 hours, giving a combined work rate of 1 over 2 and 2/9. Now we assemble the algebraic equation. 1/4 plus 1 over x equals 1 over 2 and 2/9. We now have a rational equation with an unknown in the denominator and a complex fraction on the right side. Let's not panic about the fractions. We'll simplify this step by step using clean mathematical techniques. Step 1. Look at the denominator on the right side, which contains a mixed number 2 and 2/9. Before we can do any algebra with it, we must convert it into an improper fraction. Multiply the whole number 2 by the denominator 9 to get 18, and add the numerator 2 to get 20. So 2 and 2/9 becomes the improper fraction 20 over 9, making the right side 1 over 20 over 9. Step 2. Now we clean up the complex fraction 1 over 20 over 9. Remember that a fraction bar represents division, 1 divided by 20 over 9. When dividing by a fraction, we keep the first number, change division to multiplication, and flip the second fraction to its reciprocal. 1 times 9 over 20 equals 9 over 20. Look at how much cleaner our equation is now. 1/4 plus 1 over x equals 9 over 20. So at this stage, mathematicians have 2 great methods to choose from. Method 1 is isolating the fraction 1 over x on the left and combining terms on the right into a single proportion. Method 2 is multiplying every single term by the lowest common denominator, 20x, to clear all fractions instantly. Both methods yield the exact same answer. But today, let's isolate 1 over x so you can practice your fraction arithmetic. Step 3. To isolate 1 over x on the left-hand side, we subtract 1/4 from both sides of the equation. This leaves us with 1 over x equals 9 over 20 minus 1/4. Now we must evaluate the subtraction on the right side. Step 4. You cannot add or subtract fractions unless they share a common denominator. The lowest common multiple of 20 and 4 is 20. To change the denominator of 4 into 20, we multiply both the top and the bottom of 1/4 by 5, giving us the equivalent fraction of 5 over 20. Substituting this n gives 1 over x equals 9 over 20 minus 5 over 20. Step 5. Keep the common denominator of 20 and subtract the numerators 9 minus 5. 9 minus 5 equals 4, which gives us 1 over x equals 4 over 20. Notice that 4 over 20 simplifies directly by dividing the top and the bottom by 4, leaving 1 over x equals 1/5. Step 6. When you have two equal fractions, you have a proportion, and you can solve it by cross multiplying. Multiply along the diagonals. 4 times x equals 4x, and 1 times 20 equals 20. This gives a linear equation of 4x equals 20. Dividing both sides by 4 gives us x equals 5. Now let's do a quick sanity check to make sure this answer makes logical and mathematical sense. If Tom works at 1/4 of the job per hour, and Sam works at 1/5 of the job per hour, their combined hourly rate is 5 over 20 plus 4 over 20 equals 9 over 20 of the job per hour. Inverting 9 over 20 to find their time together gives 20 over 9 hours, which is exactly 2 2/9 hours. Our solution is completely verified. It will take Sam exactly 5 hours to complete the entire job working by himself. Remember the core principles from today's lesson. First, convert time to rates using 1 over time. Second, sum the individual rates to equal the combined rate. Third, convert all mixed numbers into improper fractions before solving the rational equation. Now it's your turn to test what you've learned. Here's a challenge problem. Pipe A can fill a pool in 6 hours. When pipe B is turned on at the same time, the pool fills in just 2 hours. How long would it take pipe B to fill the pool all by itself? Use the exact same formula we learned today and leave your step-by-step answer in the comments below. Make sure you hit subscribe, give this video a thumbs up, and I'll see you in the next math breakdown.